All right. In example 1, we were doing Army inductees. What is the probability of being type O? That was 8 out of 24, which if you compute that as a percentage, do 8 divided by 24, which actually simplifies to 1 out of 3, and that is 33 and 1/3%. Okay, so the probability of an Army inductee being blood type O, yeah, 1 out of 3. In example 1, what is the probability of being blood type O or AB? Well, if you're this or you're that, then you're not just 8, but there's 8 of these and 4 of those, and if you're either one, well, then that makes 12 people total. So this is actually 12 out of 20. So 12 out of 24 people are either blood type O or blood type AB. That's 50%. Type O or type AB. In example 1, what is the probability of an Army inductee being none of these blood types? Oh, 0. 0 out of 24 had no blood type because they all have blood. Okay. In example 1, what is the likelihood of an Army inductee being at least one of these blood types? Well, I mean, to be fair, you can only be one of these, but 100%. Okay, so what is that? 24 out of 24 Army inductees, or 100% of them, have a blood type. They have at least one blood type? Well, yeah, they have one blood type, to be precise. Whatever. I don't even think that we needed, that was just a confusing phrasing right there. Being one of these blood types. 100%. 100% of the time you're going to have a blood type. If there are 3,000 Army inductees, then about how many of them are likely to be blood type A? Ooh, okay, so type A was 5. So first, 5 out of 24 is blood type A. Okay, I'm going to have to compute that. 5 divided by 24. Ooh, gross. Times 100. Okay, I got this. About 20.8 is what I'm going to say right now. Percent. Okay, so instead of equal, I got 20.8%, about-ish. So of the 3,000, so I would go 20.8%. So 20.8% of 3,000 is 0.208 of 3,000. Let's see. I get 624. Whoops. So if there are 3,000 Army inductees, then about how many of them are likely to be type A? About 624 of them are blood type A. If the chance of rain is 67% likely, then what is the chance it won't rain? Well, it's either raining or not raining 100% of the time. So 100% minus 67% is equal to 33%. Okay. 67% likely of rain, and that means 33% no rain. What is the likelihood of rolling a 3 or a 5 on a 6-sided fair die? All right, you roll a die, and there are 6 different numbers it could come up with, and this is a 3 or a 5. That's 2 out of the 6 numbers. So this is 2 out of 6 numbers possible total. And okay, that's 1 out of 3. And we could write that as a percentage. 33 1/3%. If we roll a dice 862 times, about how many times will we roll a 3 or a 5? Well, we have the percentage right here. So if we take 33 1/3% of 862 rolls, let's see, it's approximately. And let's multiply that. I get about 287.33333, whatever. I'm going to round that to about 287. About, that's right, about 287 of the rolls will be a 3 or a 5 out of the 862. All right. So, what is descriptive and what is inferential? Descriptive statistics are just organizing and summarizing data. So, descriptive statistics organize organizes and summarizes data. Make a chart, make a pie chart, make a bar graph, organize it, summarize it, compute a percentage, but that's it. Inferences, however, take the results from a sample and extend it to the entire population, and then eventually measures the reliability of that guess or that result. Okay, so let's write that out. Okay. Inferential statistics takes results from a sample, extends it to the entire population, and measures the reliability of the result. Well, hi, kiddo. I am making a video. Can you give me 10 minutes? Thanks so much. All right. Okay. I see you too. Please close the door. Thank you. All right. So in this class, sorry about the interruption there. In this class, so you're already doing some of this. You are taking some results from a sample and saying something about the entire population. For instance, let's see here. This was from a sample of 24 Army inductees, and then you kind of said, oh, let's extend it to 3,000 Army inductees. And so that is you making an educated guess or an inference about more based on this 24 Army inductee sample. Okay, so that would be an example of you taking results from a sample, extending it to say something about a bigger population. And then this part of it, so measuring the reliability, measuring the reliability of that result, that is a future math class. So whether you're going to take Quant Lit, Gen Ed Stats, or Gen Ed Math, that reliability will be talked about in a different class, in your future math class. All right, let's do this last example for this section on probability. Capital punishment. In a city with a maximum security prison, they're in the news a lot, the adult residents have been polled to determine if a relationship exists between marital status and a resident's stance on the capital punishment. Okay, so if you're sitting here and you might be disgusted either way with these numbers, okay, but these came from the residents of a city where there is a prison, okay? So just keep that in mind as you look at these numbers. Okay. Is this a situation where a sample was used? The adult residents have been polled. No. This is all of the adult residents. There aren't very many. There's 200 adult residents in the city where there's a maximum security prison. So this is out in the small town, super small town, like dinky small town. But it says the adult residents have been polled to determine this relationship. So, I don't know. Wait a minute. I'm looking down here and I'm seeing the city has an adult population of 6,000. Oh boy. Okay. So maybe this should have said, so the adult residents were polled and this is who responded? Maybe? Okay, so is this situation when a sample was used? Yes. This is 200 out of the, I got this number from down here, 6,208 residents. 6,208 adult residents. Got it. It's a sample. Fill in the table with the corresponding probabilities. Let's see. Okay. All right. There are a total of 200, and we are going to make everything out of the 200. So the 200 people were sampled, so corresponding probability. So off to the side here, 105. So I'm looking at this here, and I'm noticing that there are 105 married and in favor of capital punishment out of 200. Okay, 105 out of or divided by 200 and then turned into a percentage. I got 52.5%. And now I'm just going to go box by box and fill in the rest of this table. Opposed, 45 out of 200. 22.5%. And then the total here, what is that? 75. 75% are of the adults in this town are married. Huh. Interesting. And then let's see. Let's go blue style. Not married and in favor, 20 out of 200. What is that, 10%? Yep. Okay, so total in favor is 62.5%. Living in fear. And then not married and opposed, that's 30 out of 200. 15%. And that gives a grand total of, oopsie, so 37.5%. Okay, that makes a lot of sense. Also, you could have done 75 out of 200. And let's see what we have here. So 50 out of 200. Oh, okay, that's a quarter. All right, and then this should be 200 out of 200. And if you add up those who favor or are opposed, you get 100%. Or if you do the 75% who are married and the 25% who are not, grand total 100%. So we just filled in the corresponding probabilities, but I also want you to know that what we just did in addition to that is created a relative frequency table. They're the same. Relative frequency, or how many out of the total, is the same as a probability because it's how many we care about out of the total. The city has an adult population of 6,208 residents. About how many of them do we expect to be married? 3/4 of them. That's a lot. Let's see. I think it is anyway. I don't know. So 75% of 6,208. 3/4 of them. I get 4,656 married adult residents in this town. About how much of the city's population do we expect to be married and opposed to the death penalty? Married and opposed. That's 22.5%. So 22.5% of, wait a minute. I'm going to have to write something here. When I compute this, I'm just going to get how much of the adult population is married and opposed to the death penalty. Well, I certainly hope. So now it brings up the question of adulthood and marriage before adulthood, which is not this class's topic. There are plenty of classes that could go in depth on that. So, but I'm going to say here how much of the city's population. We actually don't know the whole population of this town. We only know the adult population. So I'm actually going to write that here in my answer. 22.5% of this, which is, okay, so I'm going to compute this. But I'm going to have to clarify that we just made an assumption here, so, or clarify the question. Oh, that does not give us a whole person here. So when I did 22.5% of 6,208 people, I ended up with 1,396.8 people. And I'm just going to go ahead and round that to the nearest whole adult. So of the adult population. Okay. So just to clarify, how likely are people to support the death penalty in this city? Let's see. Favor capital punishment, 62.5%. How likely? They are 62.5% likely. Support it based on this sample. Okay. Is each probability in the table descriptive or inferential? So here, every one of these computations were straight from the data. And so when I look at here and I say organize and summarize data, that's descriptive. This wasn't extending to the entire population. So this table, that was just purely descriptive. And each probability, is each, yes, it is this. No extension. Are the answers to number 3 and 4 descriptive or inferential? Number 3 and number 4. Ooh. So this was just, remember, 200 sampled, and this is all of the adult population. Those, definitely inferential. Takes a result from the sample of 200 and extends it to say something about all of the adults in this city. So, inferential. Extends sample to the whole adult population. Okay, so as a quick summary, what did you learn in this video? Hopefully what you learned was, well, in qualitative data, we take probabilities, and this probability is just a relative frequency, which is the percentage. And we just rephrase it with how likely is it to happen? Well, it's probably like 62.5% likely to happen. So that's somewhere between maybe and likely. And in quantitative data, we use averages. So we use both actually, but we'll get to that later. A probability is a portion or a fraction or a ratio or a percentage of the ones that were being considered out of the total. And then an inferential extends a descriptive statistic onto others. So we're hopeful that whenever a sample is taken and whenever we compute one of these probabilities, that it really is reliable and unbiased so that it represents the entire population that we're talking about. All right, so in summary, probabilities, how many are considered out of how many total? We use them a lot. We use them to make decisions, and we hope to do good research.